Now, any wire that has electricity passing through it, any wire with an electric current passing through it, will have a magnetic field. But it's going to be a very weak magnet. If it's just a wire with hooked up to a battery, it's going to be a very weak magnet. In order to make a practical electromagnet, what people do is they wrap coils of wire that are very close to each other. And this is insulated wire wrapped around, in this case, a cardboard tube. And that those coils then produce overlapping magnetic fields, which make this, the more coils there are, the more powerful that magnet is going to be, the stronger the magnetic force, because you get these overlapping magnetic fields that strengthen the overall magnetic force. The presence of an electric charge, like a balloon with a static charge or even a single wire, is not enough to, well, I guess a single wire will generate a magnetic field, but just an electric charge like a balloon won't really generate a magnetic field. Also, a magnet laid near a wire will not induce a current. You can't just put a magnet next to a wire and expect a current to be induced. A changing magnetic field near the wire will generate a current in the wire. And that's an important distinction. In fact, when Faraday first noticed the currents that were being induced in the wires he was studying, he noticed that the current was induced when he turned the magnetism on, and then when he turned it off. But just having a magnet, a magnetic field, is not going to induce a current all by itself. So, likewise, a moving charge will cause a magnetic field to form around itself. When the voltage across a conductor when voltage across a conductor is formed in a changing magnetic field, that's what we call excuse me, that's what we call electromagnetic induction. So if you took a magnet, for example, and moved it back and forth inside this tube, then you would be able to observe a current going through the wire. So it's the changing magnetic field that induces a current.